hopefully yours matches mine or pretty close to it. So what do you know? What does this, when you hit the calculate, what is it, what information is it giving you and what's it telling you? They're so shy.
Well, the standard deviation is higher in the control group, so the data is a lot more spread out and there's a lot more variation as compared to the experimental group where the data is a lot more closer together and less spread out.
Mm-hmm.
That's just one general observation.
Yeah, very good, very good. So these numbers right here, right? Standard deviation tells you how spread out they are. This number here is bigger than this one, so the numbers are more spread out for the general population than they are for the students we're experimenting on. You notice the difference in the means, right? So remember that the mean represents the average gain score, right? So if you scored a 50 the first time around and you scored an 85 the second time, then I call that a 35-point gain. So on average, the people in the experimental group gained just over 27 points, whereas the people in the comparison group gained less than 12 points. So if you subtract those two, you get a difference of 15.2. Okay, so the difference in the means is 15.2 points. All right. So is 15.2 points a lot? Do statistics say so? Yeah, they do, right? It tells us right up here, right? So it says by conventional criteria, the difference is considered to be very statistically significant. What they do is they give you what's called a p-value. The p-value is a probability, and basically what they're saying is, and the probability here is less than 1%, right? It's actually 1/10%, okay? So what that probability is telling us is, look, if you got two groups of kids, and you give them both a pre-test and a post-test, they're not going to be exactly the same, because they're two different groups of kids. So what we have to do is decide if there is a difference, and there will be, is that difference really significant or isn't it? Do we think that that difference was probably caused by something other than just random by chance? Random by chance might mean I just happen to have a group of kids that's a little bit smarter than somebody else. So of course they gained a few more points than the other kids did. So what? But if you gain a whole bunch of points more, and a whole bunch depends on what all the scores were, what those numbers were. If you can prove that one group had a big gain more than the other group did, then you can say something was happening there. And so normally when statisticians do that, they try to get within a 95% probability or better, which means that there is a 95% chance or higher that something was going on there that made those means different. And so we have to believe that something happened there, okay? Because that wouldn't happen by chance, it wouldn't happen randomly. And so you're looking for this p-value right here to be at something that is 0.05 or smaller, 5% or less, and you can see that's a lot smaller. Okay, that's why it says it's very statistically significant. In fact, it turns out, if you look at this 95% confidence interval, that means that if the difference in the means would have been anywhere from about 6.5 to 24, we could say with 95% certainty that something was going on there, that wouldn't happen just by chance. And in fact, the number we got, which was, our difference was 15.2, is on the high side of that, right? So there clearly is something going on there. You see how that works, Aaron?
Well, even if, since the percentage is so low, could we even say we're 99% confident?
We can. Yes, and sometimes you'll see them do that. The 0.01, you'll use 0.01 as the level and say we can be 99% sure. Yes. Linda?
Is it stronger to say that you're 99% sure for like a smaller interval, or would you rather say you're like less percent sure for a wider range?
Well, it depends on how you're trying to defend yourself. Normally, if you can get within a 1% interval, you're going to do it. You're going to say 99%. Now, a 0.01 is such a strong statistical significance that nobody would ever question that something's going on there. It's possible to have a 95 or 96% confidence where somebody will say, yeah, but there's still a 4 or 5% chance that. So normally, if you can crank up your percentage, you're going to do that. It's a good question. So you see what's going on here? By the way, only a third of you, or a little more than a third of you, had done t-tests before, but you all making some sense of this? Okay, you see how simple that is? You don't have to be a big statistics person to be able to do that. All you gotta do is have software that allows you to crunch it. You put the numbers in, the software will tell you kind of what's going on. Obviously, there are conceptual pieces here of statistics that we study, and we think about what t-tests mean and so forth. But what I wanted to show you here is that there are very simple, technology-driven ways of being able to measure the impact that you're having on a class. By the way, in the big picture of things then, what is the conclusion of this study? What do we know now based on this study? Yeah?
Well, were we given that the student, like the original student scores? Because if the comparison, like some of those students just could have scored like really high, so they didn't have any room to grow.
That's right.
So,
So the only thing that we know from the study, and we didn't give you this data, was that they measured the two groups at the beginning of the year to show that there was no statistical significance in the difference of their means on the pretest, which is big, right?
Right.
So I take two groups of students and I give them the same pretest, and this group scored 2 points higher than that group, but that's not statistically significant. So we can argue the two groups truly are basically the same.
okay.
Yeah. So what do we know?
So in that case, we know that if the students were on the, like generally on the same level to begin with, what the group that was the experimental group grew, like their scores went up by leaps and bounds higher than the other group. So that we can say that the teachers were, like, even with their bias towards the students, could have helped them gain more points in the end.
That's right. Makes sense? Now, we can't for sure, because this is inferential, this is kind of, I think this is probably what's going on here. We have to be really careful about assigning a cause to it and saying this is definitely why that happened, but there's a pretty strong likelihood that it is. And I think there's a huge message for us as teachers, right? You walk in the first day, and for whatever reason, I just think Megan is gonna outperform everybody else in the room, right? And I think she is my best student, she is gonna outperform everybody, I just know that, I believe that going in. I talked to her teacher last year, and they told me, wait till she gets in your class, you're gonna love it, she's gonna get A's in everything you do. And if I believe that she's golden on day one, she will become golden because I believed it. But if, on the other hand, on the first day, the students told me, look out for Taylor, he's bad news. He's failed the last 3 classes in a row, and he'll probably fail yours too. Then he walks in on day one, I'm thinking, I'm not gonna expect very much. I'm not gonna raise the bar very high. I'm not gonna ask him very many questions, I don't wanna embarrass him, he probably doesn't know it anyway. And I will tend to shut him out. And even though in the front of my mind, I know I shouldn't be doing that, in the back of my mind, I'm going to do that. Because that's the way our brains work. And you start to have these preconceived notions about who's gonna be good in your class and who isn't. And when you go into a class like that, what this study began the process of showing was that the biases we have about students and how we think they're gonna perform will influence, in many cases, how they actually perform in our classes. And that's why it's so essential on day one when you walk into a classroom that you have the belief that every child in your class is capable of learning science. Every student in your class is capable of learning math. If we don't believe that from day one, we're in trouble, right? Now, there will be students that we'll be frustrated with, and there's all kinds of things that get in the way, and obstacles and absences, and all those kind of things that happen to us as teachers. But the core belief that my students can do this, and then I'm not gonna single out and say, I'll bet these 5 can, and I'll bet those 5 never will be able to. If I believe that, that will influence what happens in my classroom. So you see how powerful it can be to collect this kind of data. And this was not a very hard study to run, right? All you gotta do is grab 2 groups of kids and measure them, make sure that their pretest scores were about the same, give the teachers different beliefs about the students, watch them work for 8 months and retest them and see what happened. You know, it was a fairly easy study to run and very numerically based, a very quantitative type of study. So you and I have talked about throughout this semester kind of 3 different types of studies, and sometimes we use a mixed design, but we've got kind of the quantitative research study, which this is an example of. Take the numbers, crunch them, see what's going on. We have qualitative studies, right? So those are the studies where we're going to be doing the interviews, we're going to be talking to students, we're going to be observing what they do, videotaping them, and talking about what they do in our classes. Remember also that we talked about mixed designs, and I tell you that a lot of action students in the past on this project have used a mixed design, where they give their students maybe a survey and have them do some writing, but they also interview them. or they have them take a pre-test and a post-test, but they also observe them in their class. And so they're using a combination of those methods. It doesn't have to be all quantitative or all qualitative. In fact, the sample studies that I have for you at Canvas that we've already looked at have a combination of those. You saw a couple of those where they've got quotes of what students said in interviews, but also some tables of data of how they performed on different tasks. And then the last one is a case study. And you have the alternative of doing a case study too. We have to be careful about case studies because they can be overgeneralized too simply. But they're sometimes pretty powerful. I actually heard a guy give a presentation last week about a case study, or a study that he's conducting. It's a case study research where he's worked with 3 students. His entire study is based on 3 students. But he has done everything he can with those kids. He's looked at their files, he's interviewed them, he's talked to them, he's watched them work in class, he's tested them, and he's focusing in on those 3 students and how they perform in the classroom to try to draw some conclusions. So instead of saying, I got 30 kids in the class and I'm going to study all 30, he has decided to focus on those 3 kids. And you have the option of doing that. There are some great studies that have been published, even dissertations for PhDs that have been studied, that are the case study of one person and how they learn something. And a very, very in-depth look at that person and how they learn, what they believe, etc., what works for them. So there's all kinds of different ways that research can be done. And what we want to challenge you to do in your final research paper, or your final paper for this class, is to come up with a methodology. It doesn't have to be detailed at this point. Notice it says a draft methodology. It's just looking at it saying, all right, I have an interest in how students use technology in learning middle school science. And so I'm going to study that, I'm going to do this with my students, etc. And here's how I plan to collect my data. I want to interview them and I'm going to ask them these 5 questions. And then I really want to give them a survey where I would do this. In fact, there's a study that was done back in 2004 where somebody did a similar thing, and here's the survey they used, and I think I want to use one just about like it. And you actually kind of lay out, here's how you would collect the data if you were going to do a study with your class. But it's a draft, because as we've talked about, when you get into the classroom next fall, and you're in a real classroom doing methods, it may be that those methods aren't going to work anymore. You're going to look at it and say, oh, I was going to do a survey, but now knowing these kids that I'm working with, I don't think a survey is going to work. I'd rather interview them. It's okay. So you change that part, But this is your thinking right now. If you were going to do a study on your topic that you were choosing, what methodology might you do to collect that data? Okay? And that's kind of the last part. It's part D. It's the last thing that you'll write about in your research paper. So as I said, the next time we get together, we're going to look at this kind of what does have to be approved by somebody else outside of this room for you to be able to do the research. And so part of that presentation will be from the Human Subjects Review Board. That is already on our common time schedule for January. It's scheduled for January 24th. So for next time we get together, no reading assignment. Yay. Make sure that you are meeting with and have identified your project advisor before the winter break. I know many of you have already selected an advisor and given those names to Wendy. If you haven't finalized it yet, that's okay. We just want to have them nailed down before we go for Christmas break. So make sure as soon as you get a person identified that you let Wendy know who your person is. And let us know if you have any questions about that. By the way, I actually created at Canvas, there's a new folder that has the 2 documents. It has the letter that goes to advisors and the list of possible advisors in it. So there's a separate folder there for you to use. Okay? Questions? That's interesting. That must have been left over from a previous class. I don't think there's any football on at all tonight. But you're free to pull up a YouTube video and watch it. All right. See you later.